Circular motion is a type of motion where an object moves in a circular path around a fixed point or axis. This type of motion is characterized by a constant radius and constant speed. What the direction of velocity changes continuously. Okay, so there are a noticeable point here. What is that? In circular motion, the speed is constant and the radius is also constant, but the direction of the velocity continuously changes and further always perpendicular to the radius vector pointing towards the center of a circle. So the velocity is always perpendicular to the radius of the circle, which is always pointing towards the center. Circular motion is encountered in various natural phenomena and everyday experiences, such as the motion of planets around the sun, the motion of spinning top, or motion of a car around a curve. So there are some example of circular motion. Now, we will think some questions related to the circular motion, and in this series, we can see that there are some questions. What factors determine the speed of an object in circular motion? This is first question. Second question is how does centripetal force related to circular motion? Third one is what is the difference between tangential speed and angular speed? Further, the fourth question is how does the radius of the circular path affect the acceleration of an object in circular motion? Can an object in circular motion have a constant speed but changing velocity? Sixth question is how does inertia play a role in circular motion? What are the some real world examples of circular motion? How does the period of rotation of an object in circular motion relate to its frequency? How does friction affect circular motion, especially when considering vehicles on curved paths? The tenth and last question is what is the difference between uniform circular motion and non-uniform circular motion? We will discuss all these 10 questions one by one. Now, the answer of first question is factors determining the speed of an object in circular motion. Okay, the speed of object in circular motion is determined by the radius of circular path. Okay, so and the centripetal force acting on the object. There are two factors. First is radius of the circular path, and another one is centripetal force, which is acting on that object. Mathematically, we can write the speed v can be calculated using the formula. This is the formula. V is equals to square root of f centripetal divided by mass of that object multiplied by the radius of the circular path. Okay, and where f centripetal is the centripetal force and m is the mass of the object and r is the radius of circular path. Next, the question is here the relation of centripetal force to circular motion. Centripetal force is the force that acts on an object in circular motion, directing it towards the center of the circular path. It is necessary to keep an object moving in a circular motion or circular path and given by the formula. This is the formula for centripetal force mb square divided by r. Okay, the answer of third question is difference between tangential speed and angular speed. Tangential speed refers to the linear speed of an object along the circular path. Okay, so when a particle moves in a circular motion, then the speed along its periphery or circumference is known as its tangential speed, And the angular speed refers to the rate at which an object rotates about the center of the circle. This is angular speed. Tangential speed is measured in meters per second, while the angular speed is measured in radians per second. This is the basic difference between tangential speed and angular speed. Further, the fourth question is, and its answer is, effect of radius on acceleration in circular motion. The acceleration of an object in circular motion is directly proportional to the square of its tangential speed and inversely proportional to the radius of the circular path. Okay, this means that the radius increases, the acceleration decreases, and vice versa. Okay, so this is the effect of radius on acceleration. Further, the answer of fifth question is possibility of constant speed but changing velocity. Yes, an object in circular motion can have a constant speed but changing velocity. This happens when the direction of the velocity changes while the magnitude speed remains constant. Velocity is a vector quantity that includes both direction and speed. Okay, but in the case of circular motion, we can see that the velocity, the direction of the velocity continuously changing, but the magnitude of that velocity will remain constant. Okay. Further, the answer of question number 6 is the what is the role of inertia in circular motion? So inertia, basically the tendency of an object to resist changes in its state of motion. Okay, it is also an law of Newton. Please comment on my video which law suggest. Okay, plays a role in circular motion by causing object to continue moving in a straight line unless acted upon by external force, centripetal force, that changes their direction towards the center of circle. So this is the primary role of inertia in circular motion. The answer of question number 7, what are the real example of circular motion? So there are some example. For example, earth revolving around the sun, spinning top, car turning around a curve, and a swing moving back and forth, and a satellite orbiting to the earth. These are the real world examples of circular motion. And the answer of our next question, relation between period of rotation and frequency. The period of rotation is the time it takes for an object to complete one full revolution around the circular path, while frequency refers to the number of revolution completed in 1 unit of time. Okay, so this is the basic difference between period of revolution and frequency. And the formula, or sorry, the relation between period of time and frequency can be given by this formula. Next, the question number 9, effect of friction on circular motion. Friction can affect circular motion by providing the centripetal force needed to keep an object moving in curved path. However, excessive friction can cause the object to skid or slide off the path. Next, the answer of the question number 10 can be given as difference between uniform and non-uniform circular motion. In uniform circular motion, the object moves at a constant speed along a circular path, while in non-uniform circular motion, the speed of object varies along the path. In non-uniform motion, the object may experience changes in its speed or direction. Okay, so remember that in non-uniform circular motion, the object which is performing the circular motion can experiences the changes in its speed or direction, meaning the speed and direction both can be changed. Okay, in the case of non-uniform circular motion. Okay, thank you so much. Like the video and subscribe my YouTube channel and comment if you have any doubt.